Okay, in this last and final session, we are actually going to see the question how to solve in like 1 minute. See, each and every question you may not be able to solve in 1 minute, but yeah, there are certain rules and regulation which will reduce the time. Okay, which you can minimize the time to solve a question. So we are going to discuss here 10 questions. Like we'll try our best to reduce the time. There are certain tricks are there. I will give you. Okay, let us start with this question. Actually, in this question, you have been given that first of all, you should check current is flowing or not. So you know that P by Q is equal to R by S is given. Then what happens? Current will not be flowing through this AB. This is balance condition of Edson breeze. So definitely it is not balanced. Like this is your P, this Q, this is your R, this is your S. So what you will do, you will find out P by Q, that is 1, and R by S is 1 by 3. So you can see that here which is greater, actually P by Q is greater. 1 is greater than 1 by 3. So when P by Q is actually greater than R by S, so when resistance ratio is greater, then voltage will be less. So less voltage will be that, and this will be high voltage. So current goes from high to low voltage. So in this condition, current flows from B to A. B to A. Current flows from B to A. Ratio you will determine. Since this condition you take P by Q. P by Q is coming to be greater than R by S. So that P by Q is greater than R by S means this will have less potential, right? So you can find out within like less than 1 minute this takes. Next question. This is another form of your Wheatstone bridge. This is another form of Wheatstone bridge. And you should know that in Wheatstone bridge, if all resistors are equal, all resistors are equal. See RR, you have got all resistors are equal, let us say. Then actually in this, the effective resistance is also on. So that will work out. So here also actually this is your P. If you rearrange it, this is P, this is your Q, and this will be your R, and this will be your S. PQRS combination, like this is PQRS if you are putting like this. So if you arrange that side, this is PQRS. All are equal. So actually effective resistance is equal to R in this condition. By equal resistance, which of resistors are connected as shown in the figure. Battery of V volt is connected between A and B. The current flowing through A, F, C, E, B. So you have to check what is A, F, C, and this is your A, and like you have to just check because this he is not asking effective resistance. So he is asking AFCB. So this is your A, this is your F, this is your C, next is EAB. So he is asking half of this current. So total current actually is equal to total voltage by total resistance. So total current is equal to I equal to total voltage by total resistance. Half of the circuit he is asking. So the answer will be I is equal to current actually will become half. So V by 2R. So the answer will be third option, because if you will not see this, the current AFCB means AFCEB, half of that, so you will get this V by 2R will be the correct answer, right? Next, this is the important thing. One thing you should remember: a heating coil is labeled as 100 watt, 200 volt. The coil is cut in half, and the two are connected in parallel. Very, very important. Everybody does mistake. So heating coil is there. Heating coil is cut into two parts. So actually resistance will become half R by 2. In the beginning it was, let us say, resistance was R. After cutting into two parts, okay, actually before resistance are cutting, so here he is asking in this condition, before heating coil was having the power of 100 watt. Coil is actually divided into two parts connected in parallel connection. The energy now. So which formula of energy now liberated you can use that? Actually, energy means you can use H is equal to heat energy is I square RT, or H is equal to V square by RT, right? This is there. But now which one you have to use? Then actually you will use, because both of them are connected with the same supply voltage. Supply voltage remains same. So here previously also I told voltage remains same. So here the heat actually is proportional to resistance. So here you will write H1 by H2 is equal to R2 by R. Right. And in this you will write after that, here you will write H1 by H2 is equal to R2 by R1. Then next R2 by R1, right. In the beginning that heat developed was, actually heat means your power you can say, otherwise power also not a problem per second. Heat energy per second is nothing but power, doesn't make any difference. Power also V square by R. So in the beginning your it was 100. In the second condition we don't know. In the first condition the resistance was R. In the second condition, they had cut into two parts and joined parallel. So they have cut into two parts means each part resistance will be R by 2 and R by 2. Right. The two part is there, they have been divided into two parts and joined in parallel means new resistance, actually first resistance was R and they will be connected in parallel connection means this is R by 2 and this is R by 2. Both of them is R by 2 and R by 2 in parallel connection means you get R by 4. Right. So actually what happens here, R get cancelled. So this time the heat will be equal to 400. Simple. The main concept is here voltage remains same. So the power or energy formula is actually inversely proportional to resistance. Here two batteries are there having the same EMF are connected in series through an external resistance R. So quickly we will find out this one, two batteries are there. So here batteries rightly connected batteries, they are not mentioning wrongly connected. So here actually given external resistance is capital R and internal resistance of batteries are R1 and R2 having same EMF. Right. So he is saying that when the circuit, the potential difference across the first battery, potential difference across this is V1. So actually you write here V1 is equal to E1 minus I into R1. So actually because same current goes here, I1, I2 will not. So EMF already you know is how much E. EMF of the first battery. So potential difference across it is given 0. So V1 equal to 0 minus current, if you have to find out, two batteries in series connection means effective EMF you get is 2E divided by total resistance, you will write R1 plus R2 plus capital R, and it is actually across the first battery. So internal resistance is R1, right? So from that if you take here this E will go that side. Okay, so you get E is equal to here 2E divided by R1 plus R2 plus capital R into R1. This will get cancelled and actually you are going to get R1 plus R2 plus capital R is equal to 2R1. Then from here he is asking the value of capital R. So capital R, what you are going to get is here in this. In this you are going to get capital R here is equal to 2R1 minus R1 minus R2. So you get capital R is equal to R1 minus. Okay, next one. So here two batteries are there, they are connected in parallel connection. Here you have to use the shortcut method, means right formula you use. Two batteries are connected in parallel connection. Then effective EMF is equal to, actually one formula is there, E1 by R1 plus E2 by R2. Rightly connected. Parallel rightly connected means positive and positive one side. Divided by how many resistance they are given is only 2. Okay, 1 by R1 plus 1 by R2. And actually, for 2, we can have the right formula also. Rightly connected in parallel. Rightly connected means positive one side. Write E1 R2 plus E2 R1 divided by R1 plus R2. And you substitute everything, get 14 volt. You can take here E1 is 18. So 18 into 1 if you write here, like if you write 18 into 1 plus 12 into 2 divided by 3. So 18 plus 24, okay, 42 by 3, you get 14 volt, right? Simple, directly you have to apply. Let's say this question, actually this is like last, the resistance in the two arms of the meter bridge are 5 ohm, 5 and R ohm respectively. When the resistance R is connected with some other resistance actually, okay, equal resistance in parallel connection, then new balancing point is at 1.6 L1, right? So here actually resist, if you know that formula for meter bridge, okay, meter bridge, you know, like you'll write here, write 5 by R. 5 by R is equal to write L1 by 100 minus L1. That is equation number 1. You know, meter bridge, P by Q is equal to L1 by 100 minus L1. When the resistance, what this word says that connected in parallel connection, another resistance is connected in parallel to this R. So he is saying when the resistance R is connected with an equal resistance in parallel connection, new balancing point is 1.6 L1. So this L1 becomes 1.6 L1. So now you will write actually 5 is 5 as it is, and this is actually you get R by 2 because you are connecting with other resistance in parallel. Then this L1 is becoming 1.6 L1. Another you get here 100 minus 1.6 L1. Equation number 2. So what you need to do is that you are going to divide the equation this. So you are going to divide equation 1 and 2. From equation 1 and 2, if you divide this, right, if you divide equation 1 and 2, this is equation number 1, this is 2. When you divide, you get here 1 by 2 and here L1 get cancelled. So you have to divide and you have to solve for L1 you have to solve. Okay, so L1 value will come. That L1 whatever comes here, actually L1 value you are going to get here 25 centimeter. After dividing, after solving, you get L1 is equal to 25 centimeter. And when you get 25 centimeter, after solving, if you divide, you will actually 5 by R will get cancelled. It will take just like this question will take more than 1.5 minutes and all that. Exactly 1 minute little difficult. So you actually will write here 5 by R is equal to L1 is 25, 100 minus L1 you get 75. So actually you get this resistance is equal to 15. Right. Main thing is this equation. Okay, this equation is main. A little calculation part is there that you have to do. So that only will take little time to find this L1, right? Now this question, let us see. This was the only one question in 2020 which was little time taking. So we have got two resistance here. Okay, so we have got two resistance, and that two resistance in that one is given, one is not given to you. Two resistance in the left. So this is your what you can say left gap is given or not given. Resistance wire connected, resistance wire is there, resistance is not saying resistance wire. In the left gap of a meter bridge balances 10 ohm resistance in the right gap. So here resistance is given 10 ohm, and here he didn't tell anything about this resistance, just wire given. and the ratio of length is given is 3 is to 2. So you can say that this is 3x and let us say this is 2x, and you don't know this resistance, let us say this is R. So again you will take P by Q, like R by 10 is equal to, you will write 3x by 2x. From this resistance, unknown resistance R is equal to, you can find out as 15 ohm. So x will get cancelled, 30 by 2. Fine. But only the last thing is twisting here. What is saying, if the length of resistance wire is 1.5 meter, it means 15 ohm is the resistance for 1.5 meter wire, right? So that is the only thing you have to be little concerned. 15 ohm resistance you have, because we are getting 15 ohm resistance wire. So 15 ohm you are getting for 1.5 meter wire. And is this saying 1 ohm? So 1 ohm resistance will be for how much meter? 1.5 divided by 15. This is the only place where you can get confused, because he is saying that 15 ohm is there for 1.5 meter. For 1 meter he is not asking. He is saying for the length. For what length? 1 ohm. So 15 ohm is 1.5 meter length. For 1 ohm, 1.5 divided by 15. That is, you get 1 by 10 meter. And 1 by 10 meter you can write as 10 to the power minus 1 into 1 meter, right? So this is 1 into 10 to the power minus 1 meter. This is the last thing only makes little standard for this. Okay, next, this one is that we have to find out internal resistance formula. So there are actually two methods are there. One is like you can understand actually what he is asking and what he has given, right? So clearly it is actually in open circuit he is saying potential difference. In open circuit, what happens? The terminal voltage is equal to potential difference. So in open circuit, whatever is given, that is your, not, this is 2.2 volt you get, and actually terminal voltage is given is 1.8 volt across the external resistance, and this resistance is given 5 ohm. So here when battery switch on, otherwise when battery use, that time terminal voltage you are getting is 1.8 volt, and in the beginning what is given is 2.2. So actually you can use this formula, V equal to E minus I into R. A current formula you can write as whatever is given, EMF divided by small r plus capital R. Small r, don't know capital R, you can use this formula. You can find out. Direct formula you want, it is given E minus V by V into capital R. Direct formula. Otherwise, from here, if you substitute, you will get divide, you will get the same formula. E is given 2.2 minus 1.8 divided by 1.8 into external resistance is given 5 ohm, right? So here you what you get, 2.2 minus 1.8 you get as 0.4 divided by 1.8 into 5. It is 4 by 18, something like 2 by 9 we can say. So 2 by 9 into 5. So you get here 10 by 9, right? Okay, let's see this one. It is like we have to find out here total power. Total power. So this two actually is parallel connection. Parallel connection, what we do is power we write P equal to P1 plus P2 in parallel connection. In parallel connection 200 and 200. So first of all you will find out their effective power, power of that parallel connections, both bulb. So 200 and 200 actually you will get in parallel connection as 400 watt. Okay, and another is connected again, another bulb is connected, that is also 400 watt. Okay, in series connection we have the formula of power in series is 1 by P1 plus 1 by P2, right? So here you will write 1 by 400 plus 1 by 400, 2 by 400, 1 by 200. So actually power in series here you are going to get is 200 watt, because if you write here 1 by 400, 1 by 400, that actually will give you 2 by 400, right? So that is one nothing but 1 by 200. 1 by power in series is 1 by 200. This power in series is 200 watt. Directly we can find out, okay, using the formula. Next one is equivalent resistance. In such kind of thing, our approach should be what? Actually, we should find out how to actually arrange them in series and parallel connection. See, this is the one resistance. This side terminal is there, you cannot shift his end, but this one can be brought over here. This point can be shifted here, because here to here there is no resistance connected, so you can shift this point to here. So when you shift this point to here, you bring this one here, so this 8 ohm and 6 ohm become in parallel connection. So 8 ohm and 6 ohm becomes in parallel connection. In that condition, 8 and 6, R1 R2 by R1 plus R2, 8 6 are 48. 48 divided by 14 you get for this. So actually you get parallel connection 8 into 6 by 8 plus 6. So here 48 divided by 14. Okay, 48 divided by 14 you get for them, and that actually will become in fraction if you do it 24 by 7. Okay, 24 by 7 you get, and again these two are in series connection. So this main thing is that this two are in parallel connection. Now 24 by 7, you can actually multiply this. I mean, you can just divide this one 24 by 7. So like you get kind of 3, 7 3 are 21, and again 3 is that 7 4 is your 28, 3.4 type. So then this two becomes in series connection, right? So actually 3.4 plus 8. So you totally get here, total in this line you get both, you have to add, means total resistance you get for this line is 8 and here 3.4, right? So 8 and 3.4, that you get 11.4, and 10 again in parallel connection, 21.4. So if you do this, actually, if you do this, here 11.4, here 22.4 is there. So if you divide this 11.4, actually you can write little approximately also you can do. If you divide this, let's say 11.4, you are dividing with 22.4, right? So actually it is like kind of 0.5 only, approximately 11, 22. So 0.5 and 5 you get 5 ohm, the effective resistance. Approximately also you can do for this one. Okay, so let us see this last question. Okay, like how to solve in shortcut method, we will try to find out this. So in this kind of question, first what we have to do is that we have to find out the resistance of the respective bulb. So first one you take, like you use the formula V square by P formula. You can say V1 square P1. The thing is that you are not supposed to do the calculation totally. You will write here 220 into 220 divided by 40. So in simplified form, if you write here, you get here 11 into 11. Oh. Resistance of the first one. Resistance of the second one you have to find out, R2 is equal to, you'll get V2 square by feet. That you actually again you will get 220 into 220 divided by, so you get here is 22 into 22. Right. So we have got two bulbs connected in series. Now, actually, the next step is like we have to find out what is the voltage drop across both of them. So that the first bulb resistance we got, second bulb resistance we got, supply voltage is there, and the first bulb actually you have got the resistance as 11 into 11. Second bulb is actually you get here 11 into 11 we have written, right, and second bulb you have got actually 22 into 22, and the supply voltage you are giving right now is 300 volt. In the first condition we are giving 300 volt, so current will find out here. Current is equal to supply voltage divided by total resistance. If you add it, actually you can take 11 into 11, you take common, and left out is 1 plus 4, and actually that gives you 300 by 5 gives you 300 divided by 5 means you get 60. 11 into 11. Now actually we have to find out voltage across first one. So that is V1 is equal to current whatever we got, 60, 11 into 11. Current into resistance of the first bulb, 11 into 11. Okay, this is current. V equal to I into R. So the first bulb is getting voltage of 60 volt. Right. Now second bulb getting how much voltage? Current already we calculated 60 by 11 into 11. Resistance is 22 into 22. So this is 2 times. This is 2 times. So here you get 240 volt. Voltage drop for the second bulb 240. For this is 240. But actually rated voltage is 220. So it is crossing the rated voltage. So this bulb will fuse. This will not fuse. Right. This is how you are going to approach to these questions. Fine.